what you are learning today is you are exploring how to represent a multi-digit number. So when you guess, till we get ready to move to our grades. What do I mean by multi-digit number? What does that mean?
Numbers that are like 10, 100.
So more digits, right? Lots of digits. Multi-digits, lots of digits. You're learning to represent them. So you're going to be representing what they mean, what the digits mean, okay? And you're going to know you're successful when you can represent the number with models and equations. So part of your modeling is going to be this. Now, whose room am I in? Miss Tom? Williams, sorry. I've been so many today. Miss Williams, do they normally write on their desk if they're writing an equation, or do they need a piece of paper? Or what
Piece of paper, but I can give them some.
They're going to get paper? Okay, so thank you. Sorry about that. Sometimes we write on our desk. So you won't need anything on your desk but a pencil and a piece of paper that Miss Williams is going to pass out for you, okay? So, it's up to Miss Williams, whatever she would like you to write on. Okay. And so you won't need your computer or any of that. So leave your desk right where it is for a second. Okay? Numbers. You're going to use models with your chips. And you're going to, and you can also draw a picture if you need to. But you're also going to need to write an equation. Remind me of what an equation is. What's an equation?
A math problem.
A math problem. Can you give me an example of an equation? 4 times 5 equals 20. Is that an equation?
Yes.
Yes, so you'll need to write those. So we're going to be exploring how to represent these numbers, and we're going to be, we'll know we're successful, so you'll know you've done what you need to do for the day when you can represent them with your models and write an equation, okay? Are you ready to roll?
Yeah.
How many of you like games?
Oh,
You like to play games? Me too. So I've been having game night with some friends of mine, and we started this new game. And we didn't finish, but we're finishing tomorrow night, y'all. And I just want you to know I'm winning. I'm winning.
With 42.
Of course I'm winning, right? And look how many points I have. 42,393 points. I got a lot. So when we get back together tomorrow night, I want to be sure I get the chips back that represent that number. Are you with me? I don't want my friends trying to cheat me and not give me what I need to represent my total. Are you with me? So what I need you to do is to show me which chips that we have there in the little box that I need to get from my friends when we start our game to be sure. And I want you to prove that the total is 42,393 by writing an equation. I'm going to need to be sure that I can prove it, because I want, if you can't prove it, it may not be true, right? I can't just say, sure, this is 42,000. So if you finish that early and you feel like you have the right thing down and you've done your model, you can do the extension, which is to create enough. Can you create that same number if you had no thousands chips? But we're not going to worry about the extension unless your group is completely done with this part and you have done our success criteria. Modeled and written an equation. So if you haven't modeled and written an equation for this, you don't do the extension. Does that make sense? Does everybody know what you're doing?
Yes.
So well, you don't? Will somebody tell them what we're doing?
I still don't get it.
You don't get it. We're going to be using these chips, and I bet your group going to help you because she said yes, she knows. So if you don't quite understand, I bet your group members, y'all can help each other out, can't you? That we are using these chips to model and show me what 42,393 looks like with these chips so I can be sure I get my points on my game, okay? And then write an equation to represent that. Are you ready?
Yeah.
All right, so start working with your groups, and I'm going to be coming around asking you some questions and taking some pictures of your models. So, set my timer. And you guys get started. Start looking in there. What do you think? She's pulling out of her box.
Make sure you cover your notebook.
Chips out. I'm going to put your chips, turn your desk a little bit. Here, why don't you just move your chair over this side?
Make sure your nose is covered when you're with your friends.
All right.
So maybe like 42,000. Yeah, 42,000.
Now all situations Is it 1,000? So you think it's 1,000 chipped? So where would the thousands be? This? There's 1,000. Oh, that's a 10. Oh, you said it's. You mean it's 10,000? Is that what you meant? Oh. Okay. So did you hear what she said? She said the 4 represents 10,000. But what is the 4? Is it 1 10,000 or how many 10,000s is that 4? 4 of them. So how many chips should she get out? Ah, so she's gonna have to look through there. And so I want y'all to work together to continue figuring out how many chips she needs for each of those place values, okay? And then I'm gonna come back and check on you. Don't forget that your model and an equation.
Okay, 2 more, guys.
All right, so talk to me about what you're pulling out here. Why do you have 3 100 chips? Oh, how did you know 3? That you needed 3 of them? Oh, it's in the hundreds place. So, oh, so which one's 1,000? The yellows, but on the number up here, which one's 1,000? The 2. So how many thousands chips are you going to need? She says 4. Why does she say 4? Okay, so look up there again. Show me one more time which number, which digit tells us it's 4,000? Oh, it's 42,000. So if it's 42,000, how many of these you need? Why would you need 6? So tell me how many thousands you have here now. 6. So how much does this equal?
42,000.
How does this equal 42,000? Oh, this is 2,000 and this is 4,000. So let's look at that 4. Is that 4 showing you how many thousands there are? If the 2 is how many thousands, what's the 4? Can it be thousands too? Oh, what do you think it should be? Oh, I'm following you. I'm following you. Gotcha. So you guys keep working on that, and what I want you to do, once you get them all modeled, don't forget part of our success criteria is to write an equation, okay? So I want to see what that equation looks like when you're done.
Oh,
All
yeah,
right.
I got the one.
Yes.
You already got the one.
Okay, I'll be right there.
Okay, now let's.
All right. You got what's going on here? What you got? Why do you all have 4 of these green chips? Oh, 40. Oh, he said 40,000. Wait, I don't see 40. I see 4. 4 10,000. I'm following you. Oh, look what he's writing here. 40,000, 2,000. So remember, part of our success criteria is to write an equation that shows the value of all these chips when they're put together. So I want you to talk about what equation that could be. And I'm wondering, our friend here, what was your name, Jalen? Jalen said this is 4 10,000, 4 groups of 10,000. I wonder what equation we could write to show 4 groups of 10,000. Y'all talk to your group, and I'll come back and check on you, okay? All right, let's come over here. Talk to me about what you got here. She did? Okay. So tell me why you have 4 of these.
Because that represents
It's 40,000. That's 40,000? How can that be 40,000? I only see 4.
Yeah.
Oh, it's worth 10,000. I'm following you. So that 4 tells you what? What does that 4 tell you you need? 4 of 10,000. Can y'all say the word, use the word groups? 4 groups of 10,000, would you agree? So what does that 2 tell you you need? 2 groups of what? 1,000. I'm following you. So it looks like you're continuing on with all those digits. So you're telling me those digits tell you the number of groups of each one you need. Is that right? So what I'm wondering is, the next part of our success criteria is to write an equation. Once you get it all modeled out, what's that equation going to look like that you're going to use? And how could you use what you said about 2 groups of to write an equation? So y'all work on that and I'll be back to check on you. All right, guys, talk to me about your model here. Why do you have 3 ones and 3 100s? Why do you have the same amount on both of those?
Because it says we're supposed to have that 42,393.
Okay, 393. So what does the 3 tell you?
The 3 tells you the value of the place.
Do y'all agree with that? Does the 3 tell you the value of the place?
What are we supposed to do with them?
So what's the value of that first 3?
The first 3 is 300.
So why do you have 3 chips? If it's supposed to be 300, why do you have 3 chips?
Because it represents the
So the 3 tells you what?
So that's it's in the hundreds. Yeah, that's right.
It's in the hundreds place, so you know you needed hundreds. And the 3 tells you what? Number of groups or the size of the group? That you needed 3 groups of 100, right? So that 3 tells you how many groups of 100 you needed. So is that, why do you have 3 ones then?
Because there's and that represents the value of 3 1.
Oh, did you hear what he said? It's hard to hear with math going, isn't it? He said that this is 3 groups with a value of 1. So here, I love your model and how you're putting out each digit is how many groups of each size. And I notice you're writing equations here. And I'm wondering what y'all think about it. Have y'all started your equations? Look at your 2 different equations here and what he has and what you have and how those are the same. And you guys keep telling me groups of. What operation could we do? Addition, subtraction, multiplication, division. What operation tells us groups of? I want y'all to talk with each other about how you could use that in your equation. Talk about her equation here, how is it like yours, and how could you use groups of in your equation, okay? I'm going to come back and check on you in a minute. Okay. Ready to go? That's your equation? Okay.
40,000 plus 2,000 20 hundreds, which is
Oh, 20 hundreds? What? You can't have 20 hundreds.
Yeah, hey, it's better than thousands.
Oh, so you're in the extension. You said if you didn't have thousands. What if you had thousands, though? How many thousands would you have used? 2. But because you don't have thousands, you had to use...
The hundreds. So that's the closest.
Okay, that's the closest one. I like how you're writing 20 hundreds. But wait a
I
minute.
figured out I made a problem for them.
Gotcha.
So 40,000 plus 2,000 plus 300.
Okay.
Plus 3,000.
Okay.
42,393. But we gotta explain how
Okay.
we got 2,000.
I love that.
20 hundreds.
So here's what I'm wondering. So you're telling me that 20 hundreds is 2,000.
Yeah.
Prove it. I mean, I see. Where's the thousands?
So the thousands would be 10 of them.
Oh, 10 of them. So could you put the 10? Is that what you're doing? Put the 10 together? So it would take 10 of those to represent 1,000. Is that what you're saying?
And then we would have to take the other 2 to get another 1,000. Both of the thousands would equal 2,000.
Okay.
So that would be 2,000 out of the hundreds.
Okay. So can y'all put all these up here so I can get a nice little picture of those? You have your, what is this? Oh, this is your 9, isn't it? I'll slide those up here. And this is your 3. So this is still 2,000? Oh, that's 1,000. So let's stack them up like that so we can see it.
40,000 plus 2,000, but also the 2,000 to equal that number.
So are you following him over here? That this, look at this, sweetheart. Tell me your name. What's your name? Justin? Preston. Preston, what does this represent again? This whole stack represents what? They are a bunch of hundreds. How many hundreds do I have here?
You got this?
Tell them how many you put there.
You got this?
Okay, so there's 10. So if I have 10 100 chips, how much does that represent? Help him out, guys. If he has 10 100 chips, how much does that represent? Let's count and prove it. 100, 200, 300, 400, 500, 600, 700, 800, oh no, 900, 1,000. So if Miss Lovelace had knocked them all over, we would have that. Okay, so I'm going to put that back together. Thank you. Let me take a picture of this. Okay, so now, I love this equation, but here's what I'm wondering. See how you all have this equation? I would call that our expanded form. You guys have been working on expanded form? Here's what I'm wondering. Can you write this same equation using a different operation? Because you said that this was how many? 40,000. So it's 4, what? 4. Okay. So what does, use the word groups of, and tell me what we have have 4 of? 4 groups of 10,000. Talk to your group. How could you write an equation that shows 4 groups of 10,000? What would that look like? Write that down. Talk to your group.
Alright, what should we do?
So, what are you putting here? How many? Wait, what? So why are you putting 10s here? Right? How many 10s are you putting? 9. What told you there needed to be 9? Great, awesome. So if there's going to be 9 here, how much is this worth? 9 10s is worth what? 90. So where are you going to put that and show that in an equation? Oh, can you do that quickly as you're going? Because we're almost out of time. So as you're putting this here, can you show me that and what it looks like as an equation? Okay? All right, so here's your equation. You have 3,000, 2,300. Why did you choose to add those all together?
So then we can get 42,307.
Okay, because you needed to prove that it was worth that much. Is that what you're saying? Oh, is something missing?
Yes.
What's missing?
The 3.
The 3. Oh, yeah.
Okay,
Awesome. So you guys would probably call this expanded form, wouldn't you? I'm wondering if there's another way you could write this. When you have your, this is 4, what? Oh, look at you with an extension. I'm glad you did that. So this 4 represents what? The 40,000. Use the word groups of and tell me what's here. How many? 4 groups of 10,000. How could you write an equation here underneath this that shows 4 groups of 10,000?
let's just write 4 chapters.
So you could write just 42,000, yeah, but how could you show me 4 groups of 10,000 with an equation? What operation means groups of? Addition, subtraction, multiplication, or division? So division we could have groups of. What's the opposite of division? We're done. So if we have 4 groups of 10,000, did you show that with multiplication? What does that look like underneath there? Okay, we have about 60 more seconds. If I was to use it using addition. Yeah, why is he writing 4 times 10,000? Why did he write that? What? Okay, but what does the 4 tell you? Use the words groups of and tell me what the 4 tells you. 4 groups of 10,000. So what does this 3 tell you? Or 2 tell you? 2 groups of 1,000. So you guys had it in expanded form first, where you added them all together. Then you wrote it this way. Let me take a picture. Perfect. Awesome. Let me make sure I got it. Take a picture of your model real quick. How's your equation? Oh, groups of. I like that. What do you mean by groups of? What operation tells us to do groups of? Huh? You don't really know? So it's 4 groups of 10,000. Is it addition, subtraction, multiplication, or division that shows groups of? Let's talk about that as our share discuss. Yes. Did you finish? Nice. I love it. Why did she write all of these? Why did she write 10,000, 10,000, 10,000, 10,000?
I wrote it 4 times because there's
4 of them. I'm following you. Okay. All right. All right, everybody. Let's come back together and let's share some solutions that I saw out and about. Okay? So let me set my timer again so that I don't spend too much time. I'm bad about that. So you guys were doing an excellent job of getting to our target for today, which was to represent multi-digit numbers, right? And to know you were successful, you had to model. Have you been modeling?
Yes.
And you had to explain your model, and you had to write an equation. Have you been writing equations?
Yes.
Yeah, so we're going to you guys are getting to that target and success criteria. So now we're going to share, and here's how this works. While we're sharing during share discuss time, you're not working on your problem anymore. Okay? You're listening. I'll put some solutions on the screen for you to look at, and we'll have some time to talk about them, all right? So I need to put your pencils down, and let's look at some of these solutions because, oh my goodness, you had some great ones. I'm excited to look at some of them. So let's look at this first one. Miss Lola took lots of pictures, so let's see. This is a little remote that freezes the projector. Oh, I see it. I got you. Thank you. So I'm going to put this one up there. I'll zoom it in a little bit. And do you want the lights on? Totally up to you all about whatever, as long as the kids. Oh yeah, that looks pretty. Except now Miss Lola can't find the freeze button. There it is. Freeze. So I wonder if we put our. Are they good? They normally work like this? Okay. Okay. All right. So here's what I want you to do. Talk to your partners about what is on the screen and why they chose to put those chips, that number of chips in those places. Okay? Talk to your partner about what's there. What are those? Why did they choose those chips? Okay, talk. Yeah. Yeah. Why did they use it? Why did they put 14,000?
Because it was like they're trying to make it their own way to where they can do it their own way to where we can, so everybody else will have a different like.
Okay, so let's come back together. You guys are doing a fabulous job of talking with each other. Oh my goodness, I'm so impressed. Are you sure you're just fourth graders and not college students? Oh, no? Just fourth graders? Okay. So, you were doing a great job of talking. I need to know, somebody who was at a group talking, why did they put 4 of the 10,000 chips? Yeah.
4 of the 10,000 chips represent 40,000 because 4 times 10,000 is 45.
Okay, so she remembers back to my score, right? There was a 4 in the 10,000s place, so we had to show 4 groups of 10,000 and they were there. So why are there 9, 10 chips? Why are there 9, 10 chips? Yeah.
Because if you have 9 chips, that would equal 90, and that's one part of like the number that we have to get.
Gotcha. So you whoever's group this was that did this model, and a lot of you did the same thing, didn't you? You all had to represent my number, didn't you? Because I can't like lose my game because someone didn't tell me give me the right chips. So you knew that each of those digits tells you what? Turn and tell your neighbor what each of those digits that were in that number tell you. Oh, come back to me. Miss Lovelace wants you to use a certain word. Actually, when you're talking, could you talk to your group about, remember I just said, what does each one of those digits represent? Remember that? I want you to use the words groups of or in your discussion. So go and turn and talk about what those digits represent. And so the reason they put 2 is because that 2 meant. That's okay. Oh, look at that. Is that okay? You want to fix it right quick? I'll take another picture.
So, they two equations, so
Okay, so come back to me. Okay, let's come back together. So I asked you to use the words groups of as you were talking. So who can tell me something their neighbors were talking about to explain what those digits in that number tell us? What do the digits tell us? Yes, ma'am, you have your hand up?
Each group of number represents a number. Like 1,000 represents 1,000. Like the 1 represents 3 1s.
Okay, so she's saying each of those digits represents how many ones, how many whatever. Somebody use the words groups of and tell me what that digit tells you. You want to do it, Nick? Go ahead.
It means 9 groups of 10.
I know that's hard to hear. She said 9 groups of 10. So that 9 tells you there's 9 groups of 10, which is worth 90, right? And the 2 is 2 groups of 1,000. What is 2 groups of 1,000 worth? 2,000, right? So, did you need me, baby? Oh, you're just standing. Okay. So, we looked at that model. So, let's look at another one that I want you all to look at. So, I remember that part of our success criteria we modeled. Did they model? Yeah, they modeled the number. Check. They did that part of the success criteria. But what's the second part of our success criteria?
That we would have to.
We had to write a what?
We An equation.
An equation, that's right. So let's look at this equation and see how it matches or doesn't match the model. We'll see if it does match. Let's zoom it in here. Oh, I think I froze it. Whoops. It's levels in technology. There we go. So let's freeze it again. Oh, it went dark. Go dark. Okay, there we go. So you see what this group wrote? What they wrote here? They wrote an equation. So why did they decide to write those numbers as their equation? And why did they write an equation? I mean, I know I told you to write an equation, but why are they putting the plus signs in between them? So turn and talk to your neighbors. Why did they choose those numbers? And why did they add them? What do y'all think?
I don't know. You know your number. This is our
Put it together.
and that would be the number that you have.
Exactly. Because otherwise you can't prove that I have 42,390.
You can't write a random number because that wouldn't be random.
That's right. That's right.
Should I tell them about like how I?
Oh, we're gonna get to that. Don't worry. Don't worry. Okay, let's come back together. So why did we write? Why did someone write? And many of you did this. Why did you write those values? Yes. You, baby.
Because those are the ones that represented all of them expanded form.
Oh, did you hear what she said? She said expanded form. But wait, I'm confused. A minute ago we had, I wish I could put the other solution up, but we had 4 chips. But now it's 40,000. Why did they write 40,000 instead of 4 chips of the 10,000? Yeah.
Because it's 4 groups of 10,000.
That's the total of 4 groups. I'm following you. So this is the product of 4 groups of 10,000. Do y'all agree with that?
Yeah.
So she wrote the value of the 4. Before, you weren't writing the value of the 4. You were modeling the number of groups of 10,000, weren't you? But the value of those 4 groups of 10,000 is 40,000. This is the value of what? 2 groups of 1,000. This is the value of 3 groups of 100. This is the value of 9 groups of 10. And then the value of 3 groups of 1. I like how you switched that. So y'all said this, she said this was expanded form. Have y'all talked about that before? Yeah, so we have expanded form here. And can you tell me in the back why we added them all together, what y'all said?
If you added them together, you would get the number that you had in your game.
I would get my 40. Yeah, so they're writing 10,000 plus 10,000 plus 10,000 plus 10,000, right? So they had their 4 10,000s. I'm wondering what is the difference between that one and this one that I'm about to show you. Are you ready? You see that one? Why did they choose to write this way instead of writing 40,000? What does this show you? Turn and tell your neighbors what this shows you. Turn and tell your neighbors. What does the multiplication show you?
It's like, it looks like
All right, so let's come back together. How was this equation like this last equation? What does this show you? So this equation, let's see, was it this other one? Yeah, that one. Oh, it's frozen still. So what does this equation show you? Go ahead, sweetie.
it's like it's the same as the other equation because like it's like it, but they use the person who wrote it, they used a different number operation and adding. So it's
Right.
like,
So she said they used a different operation. This says 4 10,000s added together. Does this show 4 10,000s added together?
Yes.
Yeah.
In different form.
Because it's in multiplication, repeatedly adding 4 groups of 10,000. You know what this is called, everybody? This is called expanded notation. Everybody say expanded notation.
Expanded notation.
So it's another way to show the value of the numbers by showing the groups of each place value. Where expanded form was the value of each place value. Remember, we had 40,000 plus 2,000. This is 4 groups of 10,000, 2 groups of 1,000, and we add them all together. So when we're thinking about our learning target for the day, did you model these numbers in various ways with your chips? Yes, you did meet that success criteria. Were you able to write it in equations?
Yes.
Yeah, so what were the 2 equations that we were able to write? The first one was what?
4 times 2,000.
So we have this one, but we also had the first one. Remember expanded form? And this equation is called what? Tell your neighbor what this one's called. Expanded notation. That's right. So you have met your success criteria today, but I want to leave you with one challenge that maybe you could pick up with tomorrow to talk about this one. I'm going to freeze it up here. Now hold on. Look at that. Are y'all looking at that?
Yes.
Does this represent the number?
No.
Oh, so here's what I'm going to do. As I'm pulling and handing out your exit ticket for the day and picking up your chips, I want you to go ahead and talk to your neighbor about, is this number, is it representing the equation? Or the number 42,393? Why or why not? Talk to your grandpa. We're passing those out.
It's